In this question, derive an expression for magnetic force acting on a straight conductor of length L carrying current I in an external magnetic field B. So, assume that there is external magnetic field. We are considering the magnetic field to be uniform. So, in this uniform magnetic field, a conductor of length, any length, let it be present over here. So, it is present in a uniform magnetic field B. So, length of the conductor, it is said that length is L, and current flowing through the let the current flowing through the given conductor is I. So what is the expression for force, magnetic force? So here in this particular case, if we zoom this particular conductor. So if we zoom it as zoom, let us zoom this one. Clear. So the conductor will be in the form of cylinder. As the conductor is in the form of a cylinder, and the current flowing through is from left to right, and it is present in a uniform magnetic field is present in a uniform magnetic field B. So that means here in this particular case, this current is due to the flow of electrons here. So electrons will be moving in opposite direction or direction of this is the direction of motion of electrons opposite to the direction of flow of current, and similarly the positive charges will be moving along the direction of flow of current. So here in this particular case, we can say that these positive charges or these electrons uh, are moving with some speed, and that speed is nothing but our drift speed in this uniform magnetic field inside the conductor. So when charge particle moves with some speed in a uniform magnetic field, then they experience a force that is given by F equal to Q into V cross P. So this is the force acting on the charge particle due to their motion in a uniform magnetic field. So similarly, just here in this particular case, as a whole of the as the number of electrons, or you can say positive charge, either electrons or positive charge which are present inside the conductor are moving in a uniform magnetic field. So that's why all of the charges will experience some force. Clear? So what how many number of charges will be present in this L length of the given conductor? Let the length is L and let the area of cross section is A. So number of electrons, so we know that number density N is defined as number of electrons per unit volume. So that means number of electrons will be equal to N into here. So N into A into L. So then here the total charge will be equal to Q equal to N into E. So N equal to N A L E. Okay. So now the force acting on the whole of the force acting on the conductor will be nothing but force acting on the conductor is nothing but force on all the charges present inside the conductor. Inside the conductor. So what is the net force on all the charges? So net force will be nothing but F equal to Q into all the charges are moving with some drift speed as current current is nothing but the flow of electrons with speed what that is called drift speed in and that the Q into Vd cross B. So Q is nothing but N A L L. Okay, this is capital L. This will be capital L given here. So N A L E into Vd cross B. Here. So as all these are constants, number density, area, and length, and here charge, these are constant for this particular case. So we can keep them anywhere else. So N A E V D cross B into L. Okay. So we know that there is a standard relationship between current and velocity. So I equal to NaeVd. This is the standardization. So that means in place of NaeVd, we can write I. So I into L cross B. So here length is a vector quantity. So we can write the force on the given conductor F equal to, in vector form, will be IL cross B. Okay. So this is the expression for force acting on the given conductor. Next, what it is saying, is it valid when conductor is in zigzag form? So this conductor present over here is a straight one. So if we take a conductor which is in zigzag form means like this. So then the current will be flowing through the given conductor with different directions. Clear? So this is the if I is the current flowing through this conductor which is in zigzag form. So again we can say that the magnetic field will be perpendicular to the what you can say the current of the flow of the direction of flow of current. Here magnetic field will be again perpendicular to any particular segment of the given conductor. Clear? Because magnetic field is moving inside. Clear? And for any particular length of the conductor, if we consider any particular length, this particular length which will be something, so then force acting on it, let the length be L1 or L2, something like that. So then force on it will be I, current flowing through the given conductor, I into L1 cross B. Clear? Because magnetic field is uniform we are taking. Similarly, force on any other segment, let the other segment be this one, let it be L2. Clear? So then force, this is force on 1, this force on 2, that will be equal to I into L2 cross B. Clear? So then what will be the net force? Net force will be nothing but sum of such kind of discrete conductors. Clear? Which are a part of the given conductor. So if we have to take the sum of all this. Clear? If we take the sum of all this, so it will be F will be equal to, net force will be equal to what we can write, summation summation I L something. You can take any expression, this force, let it be something I L let it be N, not N, it will let it be something as K or K, L K into B cross B. Clear? So I L K cross B, that means here in this particular case we have to take the sum of whole length of the conductor, then it will give you the net force acting on the given conductor. So here in this particular case, is it valid when a conductor is in zigzag form? Yes, this is valid. This is valid even if the conductor is zigzag form. So this is a question of 2 mark. Clear? So with this one you will get easily 2 mark answer. 2 mark 2 mark for your answer.